Hello students, in the last lecture we have studied some compounds of 13, 14, 15 group elements and their molecular structures. Today we have to study chemistry of some notable compounds of elements of group 13, 14 and 15. Notable compound means some of the important compounds of group 13, 14 and 15 here we have to study. For example, we have to study borax, as well as later we have to study silicones. What are the silicones, their properties, and some of the important uses of silicones also we have to study. As well as we have to study ammonia, which is the compound of nitrogen, 15th group element, preparation of ammonia, some physical properties of ammonia, and reactions or chemical properties of ammonia and uses also we have to study. So see, first of all, that is the borax. Borax is a compound of boron. Its formula is Na2B4O7. Formula of borax is Na2B4O7. Crystalline borax has formula Na2B4O7 containing 10 moles of water as hydrate. 10 moles of water as hydrate means it is a decahydrate. So its formula is Na2B4O7 containing 10 moles of water, or it is also written as Na2B4OH/4 containing 8 moles of water as a coordination complex. It is written also as a coordination compound or coordination complex. So this is formula of borax, Na2B4O7 containing 10 moles of water, that is the crystalline borax. Borax naturally occurs as a tinkle that contains 90% borax, it is found in nature as a tinkle and observed in certain inland lakes in India, Tibet, in USA, that is in California, borax is observed. Borax is prepared from the mineral colemnite by boiling it with solution of sodium carbonate. So see its preparation. Colemnite have formula Ca2B6O11. Ca2B6O11 react with sodium carbonate Na2CO3. Then here there is formation of borax. Borax is obtained or borax is formed. This is the NaBO2, sodium metaborate and calcium carbonate precipitate out. That is nothing but the preparation of borax. Now we have to study some of the important properties of borax. That is, borax is a white crystalline compound. Borax is a white crystalline solid, white crystalline compound. Borax dissolves in water and form alkaline solution. Why alkaline solution? Because here see, borax is actually salt of strong base and weak acid, that is the boric acid, orthoboric acid. So when it is added in water, then it forms strong base NaOH and weak acid orthoboric acid. So strong base is formed, therefore the solution is alkaline and it forms a alkaline solution. When borax is heated, then it first of all loses the water molecule present in it and it forms anhydride. क्या होता है, बोरैक्स हीट करने के बाद उसमें जो वाटर मॉलिक्यूल है 10 वाटर मॉलिक्यूल एज ए डिकाहाइड्रेट, वो 10 वाटर मॉलिक्यूल उसमें से लूज होते हैं, रिमूव होते हैं, और रिमूव होने के बाद जो बोरैक्स बचता है इस बोरैक्स को अनहाइड्राइड बोलते हैं. It is a borax which does not contains water, so it is anhydride. Its formula Na2B4O7 because water molecules are removed, so it gives Na2B4O7. Further that Na2B4O7 borax anhydride borax on heating gives twice of NaBO2 and B2O3. This sodium metaborate is called as the borax bead. What is this? Borax bead. And that borax bead further used in the detection of some transition elements or to obtain that color test. Okay? This borax bead test is used in the detection of transition element. When borax is treated with sulfuric acid in the presence of water, it gives salt and orthoboric acid. Sodium sulfate and orthoboric acid is obtained. Orthoboric acid is formed. Further, that orthoboric acid when treated with ethanol, it gives triethyl borate. What is formed? That is the triethyl borate is obtained when orthoboric acid react with ethanol, ethyl alcohol. So these are nothing but the properties of what that is the borax. Properties of the borax. Then see uses of borax. Borax is used in optical glass. Borax is used in the manufacture of optical glass. Second one, use of borax. It is used in soldering gun, soldering and welding करताना त्याचा यूज होतो. It is used in what that is the soldering and welding. It is used, borax is used as a mild antiseptic. It is used as a mild antiseptic, that is as a eye antiseptic. जो भी आई लोशंस, आई ड्रॉप्स होते हैं उसमें बोरैक्स का यूज होता है. दैट इज द माइल्ड एंटीसेप्टिक. ऑर्थोबोरिक एसिड इज आल्सो यूज्ड इन इट. दैट इज बोरैक्स इज यूज्ड एज माइल्ड एंटीसेप्टिक. Borax is used in qualitative analysis. It is used in qualitative analysis in the detection of transition element as a borax bead test. As a borax bead test, and it is also used as a brightener and washing powder म्हणून सुद्धा त्याचा यूज होतो. So these are the uses of borax. Borax is used in the manufacture of optical glass. Borax is used in soldering and what that is the welding also. As a mild antiseptic, that is in eye antiseptic and eye lotions में उसका यूज होता है. It is used in the qualitative analysis for detection of transition element, that is in borax bead test, and also it is used as a brightener and what that is the washing powder, or it is used in the washing. So that is nothing but the uses of borax. Now see next one compound, important compound. It is important compound of silicon. Silicones, these are organosilicon compounds or polymer which contains R2 as a repeating unit, R2SiO. R2SiO. This R2, R, Si, double bond O, and here R dash O. As this unit contains that C double bond O, so ketones, so here silicones. कार्बन में अगर C double bond ग्रुप आता है कंपाउंड में, कार्बन कंपाउंड्स में, तो उसे कीटोन्स कहते हैं. इधर सिलिकॉन के कंपाउंड में C double bond group और CO group, SiO group is there, so they are called as the silicones. They are known as the silicones. See the preparation of silicones, and after that we have to study some of the important properties and uses of silicones. Silicones are prepared from alkyl chlorides. Alkyl chlorides, when treated with silicon, here see, in the presence of copper as catalyst, then it produces this dichlorosilane. Name of this compound is dichlorosilane. This dichlorosilane undergoes hydrolysis. In this hydrolysis process, two chlorine atoms are replaced by two hydroxyl group. Two chlorine atom replaced by two hydroxyl group, and this is dihydroxysilane, right? Dihydroxysilane, further n moles of this dihydroxysilane undergoes the polymerization, and there is formation of silicones. So this is nothing but the n times that R2SiO. Here R means methyl group, and therefore that silicones are formed. They are polymers, means that contains the many repeating similar unit. It is Si, CS3, CS3 and this O. So they are nothing but the silicones. So don't forget that silicones are prepared from alkyl chlorides and silicon in the presence of copper as catalyst, heated at about 573 Kelvin to give dichlorosilane. Dichlorosilane on hydrolysis gives dihydroxysilane, and dihydroxysilane undergoes the polymerization, and that produces the silicones. Silicones are obtained or silicones are formed. Now we have to study properties of these silicones. After that we have to study important uses of silicones, and one more important compound of nitrogen that we have to study. It is nothing but ammonia. We have to study about the ammonia also. So see, properties of silicones. See, properties of silicones. Properties of silicones. First one property of silicone, it is used as water repellent. It is used as water repellent. Water repellent म्हणून त्याचा यूज केला जातो. Wherever the waterproof material, water repellent materials are manufactured or prepared, in that case there is use of the silicones. As well as silicones or these compounds are water repellent. It is water repellent. Then second, it is a thermal insulator. Thermal insulators. Thermal insulator means it does not conduct the electricity, or thermally they are high stable. Highly thermal stable means which can stand at high temperature also. It can stand at the high temperature also, thermally stable, high thermally stable. Then next one property, it is silicones is electrical insulator. It is what that is, the silicone is insulator, electrical insulator. It does not conduct the electricity in uses we will study. Therefore, it is used for insulating the electric wires. It is electrical insulator. Then next one property, that is they are resistant to, these compounds are resistant to oxidation. means they cannot easily undergo the oxidation, or they does not oxidize, they are resistant to oxidation वे chemical reaction मध्ये यांचं oxidation होत नाही. And chemicals also, these are the properties of silicones. Now see uses of silicones. Uses of silicones. So silicones are used as insulating the electric wire. Wire insulate करण्यासाठी त्यांचा यूज होतो, because they are electrical insulators. So they are used in insulating material. In insulating material that is in the electric appliances, there is use of this material to insulating the electric wire, that is insulating material, electric appliances. Next one use, that is the waterproofing fibers. Waterproofing fibers. Waterproofing fibers are manufactured by using the silicones, because we have studied they are water repellent, so they are used for waterproof material or waterproofing fibers. Then they are also used as sealant. Sealant म्हणून त्याचा यूज केला जातो to seal something, that is they are used as sealant, as well as they are used as high temperature lubricant. High temperature lubricant. They are used as high temperature lubricant as they are thermally highly stable at high temperature. Therefore, they are used as high temperature lubricant. So these are nothing but the uses of silicones. Now, one more point about this we have to study, that is the next one compound of this 15th group element. We have to study ammonia. We have to study what that is the ammonia. Molecular formula of ammonia is NH3. We have to study some important points about the ammonia, like methods of preparation of ammonia, physical properties of ammonia, chemical properties of ammonia, and lastly we will study important uses of the ammonia. First of all, see reactions used to prepare what that is the ammonia, that is preparation of ammonia. Preparation of ammonia. Ammonia on small scale. On small scale in laboratory, it is prepared from the different compounds, like the urea is used to prepare the ammonia. On hydrolysis, urea produces ammonia, as well as some salts of ammonia produces on hydrolysis the ammonia. So that reaction, first of all we have to study preparation of ammonia from what that is the urea. Small amount of ammonia is also present in air and soil. It is small amount of ammonia is also present in air and soil. And here now see urea on hydrolysis. Urea on hydrolysis gives ammonia, forms what that is the ammonia. See the reaction, the formula of ammonia, NH2, urea, C double bond O NH2 plus H2O. There is formation of twice of NH3. This is nothing but ammonia formation is take place, and before that actually here there is formation of ammonium carbonate. Ammonium carbonate, and this ammonium carbonate on further heating produces the ammonia, NH3, here 2 moles, then H2O, and carbon dioxide gas is formed. So this is formation, this is preparation of ammonia from urea. Urea on hydrolysis, here it is balanced by taking 2 moles. Urea on hydrolysis produces ammonium carbonate. Ammonium carbonate, this is actually the reversible reaction, further decomposes to produce ammonia, water, and in this reaction carbon dioxide gas is liberated, carbon dioxide gas is given out. Now second one, reaction used to prepare ammonia on small scale, that is nothing but the preparation of ammonia from ammonium chloride. Ammonium chloride is hydrolyzed or treated with calcium hydroxide, it produces ammonia, then calcium chloride, and here there is formation of H2O as byproduct. So here balance equation by taking here 2, and here also you have to take 2, and here what, that is the twice of H2O, that is nothing but the reaction in which the ammonia is obtained or ammonia is formed or ammonia is obtained. Then see the next one, reaction that is in which the ammonia is prepared. Third one, salt, that is the ammonium sulfate, when treated or reacted with sodium hydroxide, then here it produces ammonia, byproduct sodium sulfate and twice of H2O. So here there is formation of ammonia. In this way, on small scale, ammonia is prepared from urea by hydrolysis. Ammonium chloride salt, when treated with calcium hydroxide, it produces the ammonia. Ammonium sulfate, when hydrolyzed by using sodium hydroxide, it gives or it produces the ammonia. In this way, this is nothing but formation, or it is the preparation of ammonia. Now on large scale, industrial scale, ammonia is prepared by Haber's process. Ammonia is prepared by the Haber's process. So what is the Haber's process? In this process, nitrogen gas and hydrogen gas in industry heated at about high temperature and under the high pressure, that is 200 atmospheric pressure near about, then they undergoes this reaction and there is formation of ammonia. You see, nitrogen gas plus hydrogen gas, that is in the presence of Fe as catalyst, K2O as a promoter, at about 200 atmospheric pressure on heating at 773 Kelvin temperature, there is formation of ammonia. In industry, ammonia is formed. Why the reaction is take place at 200 atmospheric pressure? Because here one volume, this is 3 volume and it is 2 volume. So here what happens? 4 volume react and 2 volume form. Volume decreases, therefore reaction is take place under the pressure. If pressure increases, volume decreases, and therefore here when there is formation of ammonia takes place, then always it is take place under the pressure and at high temperature. So this is preparation of ammonia on large scale, and this reaction is known as the Haber's process, or it is a Haber's reaction to obtain the ammonia. Now see the next one point here, we are to study some of the properties of ammonia, that is nothing but physical properties. First of all we will study physical properties of ammonia. Physical properties of ammonia: it is a colorless gas with pungent smell. Pungent smell. It has no any specific color, but it has pungent smell, unpleasant smell, यानी क्या बदबू आती है. So it is also found in cattle sheds, as well as it is also found in public urinals, that ammonia gas is formed in cattle sheds, यानी कि जानवरों के गोठे में, पब्लिक यूरिनल्स में अमोनिया फॉर्म होता है. सो इट हैज पंजेंट स्मेल, कलरलेस गैस विथ ए पंजेंट स्मेल. सेकंड वन property, that is physical property of ammonia, is what? That is the freezing point. Freezing point of ammonia is 198.4 Kelvin and the boiling point of ammonia is 298, that is nothing but the 239.7 Kelvin. Ammonia is basic in nature. This substance is basic in nature because when it is dissolved in water, then it forms alkaline solution. Weak alkaline solution is formed. So that we have to study in chemical properties, chemical reactions, chemical properties or chemical reactions of ammonia. First one, that is with water. Ammonia when added in water, then it form this equilibrium reaction, that is ammonium ions and hydroxyl ion. Aqueous solution of ammonia contains the hydroxyl ion, therefore it is basic in nature. This compound is basic in nature as it form the aqueous, in its aqueous solution hydroxyl ions are formed. Hydroxyl ions are obtained. So therefore basically this urea which produces the ammonia in water, so that solution's form is basic in nature, or it is what? That is the basic solution. It forms the basic solution. Another one reaction which shows the basic property, that is with acids, mineral acid, it forms salts. It forms salts. Like here see, ammonia when treated with HCl, it gives salt ammonium chloride. As well as when ammonia is treated or reacted with sulfuric acid, then it forms the salt ammonium sulfate is obtained. Ammonium sulfate is formed. There is formation of ammonium sulfate. Ammonia when treated with HCl gives ammonium chloride, and when ammonia is treated with sulfuric acid, it gives the ammonium sulfate. This reaction shows that the compound is basic in nature because these are acidic in nature. So if any substance with acid forms salt, that substance is basic in nature. See some another one properties of what? That is the ammonia or reactions of ammonia. One more important property of ammonia here you have to remember, that is in physical property. Ammonia is highly soluble in water. It is what? That is the highly soluble in water or highly dissolved in water. Highly soluble in water. That is physical properties. Now next one, chemical property or reaction of ammonia, that is aqueous solution of ammonia precipitate the hydroxides, like what? That is the zinc sulfate. Aqueous solution of ammonia is ammonium hydroxide, and there is formation of zinc hydroxide precipitate, and byproduct obtained is ammonium sulfate salt. So balance equation by taking here 2, that is zinc sulfate when treated with aqueous solution of ammonia like ammonium hydroxide, there is formation of white precipitate of zinc hydroxide is obtained. Zinc hydroxide is formed. Next one reaction, that is the ferrous chloride FeCl2 salt when treated with ammonium hydroxide 2 moles, then it will produce as Fe2O3 containing X moles of water. That is formed Fe2O3 containing X moles of water, plus here ammonium chloride is obtained. So that is nothing but the precipitate obtained. Its precipitate is formed. Its precipitate is obtained. That is nothing but the formation of precipitate when it is treated. Its aqueous solution is treated with this salt. Its aqueous solution when treated with this salt like zinc sulfate, ferrous chloride, then there is formation of what, that is the white precipitate of this substance, and here oxide of ferrous is precipitate out. Oxide of ferrous is precipitate out. That is the properties of what, that is the ammonia. Then see next one, chemical property of ammonia, that is it forms complexes. It forms the complexes. For example, copper plus 2 ions reacts with ammonia and there is formation of CuNH3 by 4, here 2 plus has tetraamine copper. This complex is obtained when it reacts with the copper ions in aqueous solution. Here also aqueous solution. Then see silver chloride when treated with ammonia, or ammonia when reacted with silver chloride AgCl, then it forms this complex AgNH3 by 2 and here Cl. Diamine silver 1 chloride. Name of this complex is diamine silver 1 chloride. So ammonia is also forms the complexes with the ट्रांजिशन मेटल आयन. ट्रांजिशन मेटल आयन के साथ अमोनिया अगर कंबाइन हुआ तो वो कॉम्प्लेक्स फॉर्म करता है. कॉम्प्लेक्सेस म्हणजे कोऑर्डिनेशन कंपाउंड्स आर फॉर्म देयर. एंड लास्ट वन पॉइंट अबाउट द अमोनिया, that is the uses of ammonia. One of the important use, that is it is used in the preparation of fertilizers like the ammonium diammonium phosphate, ammonium sulfate. So that fertilizers which are used in agricultural field, they are prepared from the starting with ammonia. Diammonium phosphate, ammonium sulfate, they are prepared from the ammonia. Ammonium nitrate also. Manufacture of inorganic compound like nitric acid. Nitric acid is prepared from ammonia. In the preparation of nitric acid, there is use of ammonia, as it is used as refrigerant. Refrigerant म्हणून याचा यूज होतो. That is, it is used in cooling plants. Cooling plants मध्ये to lower down the temperature, there is use of ammonia as a refrigerant to decrease the temperature. Cooling plant मध्ये याचा यूज होतो. There is use of this compound, that is the refrigerant. And one more last one use, that is it is used as laboratory reagent in qualitative analysis में इसका यूज होता है कि to find out, to detect some radical metal ions in the detection of element. It is used in laboratory reagent or as a laboratory reagent. So this is the study of some important compounds of group 13, 14 and 15th element. So this is about the p block element, that is group 14, 15th and 13, 14th and 15th elements. Okay.